everybody, now the time is 11. So, on behalf of the Dr. NTR University of Health Sciences, Vijayawada, we welcome you all, and particularly today's chief guest and a presenter, Professor Aarat Kalra. So, is IIT New Delhi, professor in biomedical engineering, energy and electron transfer, magnetic field effects and biology coordinator. So we welcome you, sir, all the way from Delhi. And he's speaking today on a quantum biology from molecule to medicine. And as a part of the every month, we are conducting a webinar on different topics. So our principal secretary to Honorable CM Pradyumna Garu. So we wanted to, because since our Chief Minister of Andhra Pradesh, Nara Chandrababu Naidu, has got a great vision, started Quantum Valley at Amravati. So the doctors, why don't the doctors? And we can also start this course for the undergraduates, and also we had with us the Secretary Paramedical Board. Even we can start a diploma course on this subject. Physics is the one where recently I've been there in All Indian Institute of Mangalagiri. I'm a scientific committee chairman with the director and all. And there is a term called electrical engineering. So the doctors can tie up with the IIT colleges, whether from Delhi or Hyderabad or Tirupati, so that the combined course can come out, because the most of the equipment in the radiology equipment and then the phototherapy, all this quantum will be used. I'm happy that we welcome you, Aarat Kalra, having come all the way from New Delhi. So you'll be speaking today on a quantum biology from molecule to medicine. So this is what I think. This introduction of the quantum physics, whatever this one is there, we should have a nod from the NMC. We'll be because I'm also the member of National Medical Commission, so we'll be speaking to the Abhijit, our chairman, and the President Ramesh Karu, that in very soon we'll be starting these courses probably. So the diploma course we can start this one. So with these few words, we welcome you for this webinar. I request Dr. Sudha, Director of Publications, she'll read the biodata of Aarat Kalra.
Thank you, sir. Good morning, Honorable Vice Chancellor, sir, respected Registrar, sir, respected Pradyumna, sir, Satyanarayan, sir, distinguished principals, faculty members, and today's honored guest. Good morning, one and all. I welcome you all for today's WebEx meeting on quantum biology from molecules to medicine by Professor Aarat Kalra. A brief introduction about our honored guest. Dr. Aarat Kalra academic journey reflects a remarkable commitment to interdisciplinary science. He earned his BSc honors in chemistry with distinction from Dailabad Educational Institute, followed by an MSc in biology from McGill University. He then completed his PhD in physics at the University of Alberta under the mentorship of Jock. Subsequently, he pursued postdoctoral research at Princeton University with Gregory Scholes, where he contributed pioneering work on microtubule electronics. As a principal investigator of the Molecular Electrobiology Research Group at IIT Delhi, Dr. Aarat investigates how living cells respond to light and electrical signals in modern medicine. His research seeks to uncover the fundamental physical principles that enable cells to transform electrochemical and photochemical signals into biological functions. By understanding how these process changes in disease, his work is opening new possibilities for innovative diagnostic and therapeutic strategies at the intersection of the bioelectronics, photochemistry, and cell biology. Today, our Honorable Vice Chancellor Sir, Registrar Sir from Dr. NTR University of Health Sciences continues its mission of advancing excellence in health sciences, education, and research. It is especially fitting to host a scientist whose work bridges physics, biology, engineering, and medicine. Please join me in extending a warm welcome to Dr. Aarat Kalra. We look forward to learning from his insights and benefiting from his inspiring scientific journey. Thank you.
Thank you, Dr. Sudha. So, before starting the lecture, I request Sri Pradimna Garu, our Principal Secretary to Honorable CM to um, say a few words regarding this.
థ్యాంక్ యూ అండ్ గుడ్ మార్నింగ్ టు ఆల్ అండ్ అందరికీ నమస్కారం అండి. ఈ అత్యంత కీలకమైనటువంటి అత్యంత ముఖ్యమైనటువంటి ఒక కాన్ఫరెన్స్ని సమావేశాన్ని ఏర్పాటు చేసినందుకు వీసీ గారికి మరియు ఇతర సిబ్బందికు అందరికీ నేను ధన్యవాదాలు తెలియచేస్తూ అభినందనలు తెలుపుతూ ప్రొఫెసర్ ఆరత్ కాల్రా కూడా ఈ యొక్క సమావేశానికి ఆహ్వానిస్తూ నేను ఒక 7 to 10 minutes నేను ముఖ్యమంత్రి గారి ఒక విజన్ను దీనికి సంబంధించి ఏముంటుంది అనేది కూడా మీకు అందరికీ తెలియచేయడం జరుగుతుంది. I will now speak in English because I think Mr. Kalra is not very familiar with Telugu. So I welcome all. See, now why we are having this conference, because it is very important we understand the future of medicine. If we don't understand the future of medicine, whatever we have achieved in medicine as a country, as a state, we will lose the advantage, we will lose the initiative. So what is the future of medicine? And future of medicine is definitely technology. Future of medicine is very personalized medical care. The future of medicine is holistic. It will no longer will be disease oriented, it will be patient oriented. And the future of medicine is that the difference between medicine and engineering today in our curriculum or in our education setup, we almost treat engineering and medicine as two parallel different streams which never will meet. Even from +2 standards, the separation becomes very obvious. But I think the future of medicine is not going to be separate. In fact, it will be an integrated one. Then we realize that because patient becomes the core of the medicine, the medical care, because every patient of tomorrow will be extremely aware of himself or herself, will be knowledgeable, will be tech oriented. So it's not that simply a doctor says and the patient will start listening. Even today, many of the doctors are facing problem with Google doctors or AI doctors, because patients are referring to this and they're arguing with the doctors. So that is something which is inevitable. So the future of medicine will be and integrated, because of the advancement of technology, because of the advancement of the personalized medicine, and also because of the advancement of awareness of the patients. The future of medicine will also be an integrated approach, in the sense I am not sure whether this current difference of how allopathy, homeopathy, naturopathy will exist. Now any treatment will be a holistic treatment, and this has already happened. For example, 30 years back, I never saw any doctor trying to advise patients about yoga, meditation, pranayama. Today, if you go to any doctor, if there is, especially when it comes to non-communicable diseases, along with the medicines, he is prescribing all these activities. So now itself the integration is happening. and the proof of what is going to come can be very well seen in Sanjeevani. So Sanjeevani is a digital public health infrastructure with which the government of Andhra Pradesh under the under the leadership of the Honorable Chief Minister has developed. If you study Sanjeevani, you will realize that whatever I am speaking now is already taking shape. It is already taking shape in a very small way, and in the coming years, you will realize that whatever I have said probably is going to happen sooner than later. So this is this is the future of medicine. Future is technology. Future is personalized medicine. Future is holistic, individual oriented, patient oriented medicine, medical care, not not a not a disease oriented medical care. And future is where the engineers and the doctors both will sit together and try to find out what is the best possible the healthcare which can come into being. The future of medicine is also very preventive. Now when you are talking about preventive medicine, we also are talking about the entire integration of technology. Today medtech is nothing but a very good example of integration of engineering and technology. Your gadgets, your Apple watches, everything is a proof of, everything is a signal of what is going to come. If this is the future, the question is, are we ready for that future? And we, in order to be ready for that future, I think this is the conference. I think this is like a preliminary conference to make us ready for that future. We must train our students, our doctors, to meet the future demands. Otherwise, our curriculum, our pedagogy will become irrelevant, and the advantage which India as a nation and the Andhra Pradesh as a state, which is having, will soon fade away if we don't make these necessary changes in our curriculum and approach now. It is already high time. So please understand this important development in the world and respond accordingly immediately. Your processes, your procedures for changing the curriculum are all secondary to the primary need of changing the curriculum. So the need has to be superior to the process. The process and procedure cannot override the need. The need is the adapt to the curriculum should adapt to the changing trends. In fact, uh, in the engineering, when it comes to technology, whether it is quantum or AI, so in the engineering, I am seeing the engineering branches, engineering section of our education has responded much earlier and faster than the medical branch, which is obvious, because the technology developments are coming from that side. But I think it is high time the medical fraternity, medical branch also responds to it immediately, so that we start leading the world healthcare. So India as a civilization must lead the world healthcare, otherwise it will be a great injustice to the world. So now, couple of things, a couple of examples, which when I was talking to these companies, especially quantum based companies, and Professor Arath also had mentioned to us, uh, you know uh, uh, the for example, uh, one person came to me and said that he, with the help of quantum computers, he'll put nanoparticles in the blood. Okay, he'll inject nanoparticles in the blood, and with the help of quantum computers, he will be able to understand the toxicity in the blood, which eventually will manifest into a disease after several years. So this is the best example of how technology is helping us to avert the disease, to prevent the disease, rather than to respond when the disease actually comes. So this is going to happen whether we like it or not, whether people have some uh, you know uh, some ideological issues with it or not. This is already happening, and it is going to happen, and therefore we must respond to this. Now therefore this conference is like a preliminary sort of a I should not say preliminary, this conference is trying to sensitize everybody about the need for responding to these changes. And for me, the takeaway from this conference would be that a committee sits, and it incorporates this the concept of bioengineering into the regular curriculum. Okay, that is one. Second, we must also think of, and it is not happening in medical sector the way it is happening in engineering sector. One is imparting the necessary instructions to the curriculum. Second is we must have an industry tie-up. We must have tie-up with all the biotechnology companies, the companies which are involved in drug discovery. We must have tie-ups with them. We must be able to start accelerators and incubators in our colleges. We must encourage the students to to go into the startup culture. So it's simply not that once becomes doctor and starts doing doctor. So that is one stream. In fact, if you see the world over, there are two types of doctors which are emerging. One is a doctor who is involved in addressing the healthcare. The another is a doctor who is involved in biotechnology, who who understands, who tries to understand your your biology, the molecules, the proteins, and he tries to work more in the dry lab than in the wet lab. Okay, this is the second stream of doctors, and increasingly there is going to be demand for this second stream of doctors as well. So therefore we should aim for not only changes in the curriculum, but also we should have active partnership with the industries to understand what is the demand, what are the types of people they need, and whether our doctors are skilled enough to meet those demands. And third, we should also encourage the startup culture within our universities also. In fact, we are seriously looking at establishment of a bioengineering hub. You see, what are the there are many uh, you know uh, there are many research done on what are the future technologies. So, and the sum and substance of these research is there are three technologies which are going to define our future. One is quantum and AI, the second is green energy, the third is bioengineering. These are the three fundamental technologies which are going to define our future. So therefore we must adopt these three things in our. Obviously green energy is something which is not immediately relevant to this particular discussion today, but quantum AI and bioengineering is the core of our discussion. So we must start uh, bioengineering uh, hub in Amravati, in which could be in a combination of public institutions and industry partners, which not only talks about skilling the people, skilling the doctors, but it not only talks about changes in curriculum. Of course, changes in curriculum is done by the existing setup, so that doesn't need a hub. But this bioengineering hub should be a futuristic hub, which will talk about all these things, which will have accelerators, which will have active interaction with the uh, you know uh, with the drug companies, and which will do translational research. Only research is not enough. The research should translate into something, into a product which is usable by the society. So we CM has already announced the establishment of a biofoundry, and I think some of the people I also introduced to the vice chancellor also. The biofoundry is a significant part of a significant subset of bioengineering. So bioengineering, but it still remains a subset. So we are now thinking of a bioengineering hub in Amravati, where biofoundry will also be there. So these are the, these are, say, drug discovery. Drug discovery is something which we have to immediately understand that it's not going to take now years and years to come to a formulation because of quantum computing. So maybe drug discovery will happen in months with the help of the dry labs and wet labs powered by computation, quantum computers. So these are the futures. So therefore, please, uh, unlike engineering where we went to skilling first and now we are thinking of including the new skills in the curriculum. Fortunately, in this sector, I think we are doing the reverse. We are trying to immediately put few things in the curriculum itself, so that we are not late. So with this intention only, I had requested the VC and I had requested Professor Aarat to have detailed interaction with him. Interactions are going to happen. It's endless interactions are going to happen, but we should also keep in mind what is the outcome of this interaction. For me, the outcome would be the immediate changes in the syllabus. Second will be formation of a bioengineering hub, and third is an ecosystem where research, skilling, drug discovery, products will start, design and development of products will start simultaneously. So we are looking for a larger, these are the three takeaways for me in this conference. Kindly see that your discussions lead to some actions. Otherwise we end up discussing and eventually nothing comes out. We are not talking about here research, we are talking about translation research. Okay, so please bear this in mind. This is not a purely academic session in that way. It is a translational academic session. So, and therefore I was thinking that some industry partner should have been ideally part of this session, but we forgot. But anyway, there's always another chance to have. So this is with these words, I once again thank the Vice Chancellor and his officers for organizing this conference. I thank Professor Kalra for coming here. I also thank the department for helping us organize this conference. I think IIT Tirupati Director Satyanarayana Sir is also online. I thank him for coming. I thank all the doctors and all the faculty members who are involved in this conference. I extend them you know lot of wishes for them to come out with a very very robust curriculum. Today what you are doing, please understand, today what you will do will be a direction for the entire country. So therefore please be aware of it, and come out with some translation things by the end of the day. Thank you very much. Thank you.
Thank you, sir. I request Satyanarayana, Professor IIT Director Tirupati, I request him to speak to you few words. Satyanarayana is there? Okay. Before that, I request the Director of Quantum Values, Sridhar, to say a few words before starting the lecture.
Thank you, sir. So, respected Pradyumna sir, Secretary to the Honorable Chief Minister, respected Satyanarayana Garu, IIT Tirupati Director and Chairman of the Expert Committee, Amravati Quantum Valley, respected Chandrashekar Garu, Vice Chancellor, and Professor Aarat Kalra, Professor at IIT-Delhi and AIMS, and all the medical fraternity and doctors who are joining on this occasion. Thank you so much and a warm welcome and good morning to you. So my name is Sridhar. I'm the Mission Director for Amravati Quantum Valley. So Amravati Quantum Valley is emerging as a deep tech hub with centered around technologies in quantum, AI, semiconductors, and bio. So with all these main themes, Honorable Chief Minister has created a vision for building Amravati as a deep technologies hub. Would like to give a quick outline so that because we rarely speak to doctors, we mostly speak to the technology teams. But I would like to take this opportunity and to give a little overview of what is going on at Amravati Quantum Valley. So at Amravati Quantum Valley, so we have created a vision for making this as one of the top 5 global hubs. We have a very well-defined mission that was created in consultations with all the participants of experts from the country, and we created something called Amravati Quantum Valley Declaration. And we have now operationalized this Quantum Valley Declaration through these 5 pillars, so which are working together with different stakeholders and building this entire vision. So the first pillar is the state of the art infrastructure. So we are getting a, a state of the art iconic infrastructure buildings at Amravati region. So these buildings will stand out and inspire all the people working on technology. So this is a 9 million square feet space which can accommodate about 88,000 people. So we are expecting a lot of technologists, doctors, everybody to come and work in this space. Then we are bringing the state of the art quantum computer, so which is the best machine that is available today. So which is 20 qubit quantum machine. So with an investment of about 1,000 crores completely from the private investment. So this machine will allow us to do very, very inspiring things, mainly things like working on algorithms for drug discovery. So working on materials for sensing. These sensors will in turn help us to build quantum sensors, which will transform the diagnosis. So we also have a security angle here. So our next generation security systems will be completely different because these quantum computers are extremely powerful. They also create some security risks, and we need to protect ourselves from this risk. So we are creating a complete infrastructure that is an integrated ecosystem at Amaravati Quantum Valley. The second pillar is the hardware components. So typically India is very good at software. So this time we have focused more on the hardware, just like unlike 1995, so where we missed the hardware revolution. So this time the vision started with building hardware components. So here we have two test beds that are already established at Meda Towers and SRM University. So this is a collaborative effort from multiple universities across the country coming and setting up a quantum computer and created an IP called dilution refrigerator, so which will have multiple applications. So in India, we have never gone below 150 degrees temperatures to see how our materials behave or how our sensors behave, or there might be many applications in healthcare. So at these cryogenic temperatures. So we now have an opportunity to test all our innovations going to this kind of temperatures, minus 250 and down. So we can go up to minus 273 degrees, absolute zero temperatures, into millikelvin temperatures, and see how different materials behave, and these materials can be used as sensors. So there's a great opportunity here. So this is a kind of hardware ecosystem that is shaping up in Amravati. The third pillar is on software innovation. So here, when we have this 1,000 qubit quantum machine, we build state-of-the-art algorithms which will accelerate drug discovery. So throughout the world, so all the pharma companies today are working on quantum technologies. In US, there is an initiative called QFarm where the top 17 pharma companies have come together and started learning quantum. In Germany, the same thing is happening. So you name any big company, so they're working on building new drugs using quantum computers. So there's a good chance that across the life cycle of drug discovery, so there is an opportunity to cut down the timeline significantly, and our drug discovery life cycle will significantly improve. So may come from 10 years to 7 years or even less, and we can do some of these studies very, very fast. AI itself is accelerating it, and quantum is like putting AI on steroids. So now you can imagine the kind of power that we are getting it. So on software, we can do very, very interesting things. There are many applications for banking, defense, and manufacturing. So these are other innovations that are happening. So, and we're also building an operating system for quantum computer itself because the technology is shaping up, and that is another important item required. The fourth pillar here we are working on is some talent. It's very important that we create a robust talent which work closely with the ecosystem and then fuel all these other pillars. So we have trained so far about 110,000 people on foundational quantum skills. We have a target of about 2 lakh people this year, and again about 5,000 people trained on deep skills, and then on the allied skills we have about 200 people who are getting trained on these skills. So these people are available for startups here which are coming in Amravati, and also for institutions who are interested to explore quantum. So the trained resources that are available, and and we closely work with several startups across the country and research institutions. So today we are hosting many of the research institutions like CSIR Labs, DRDO, CDOT, CDAC, and all these companies are setting up their offices, and they are taking people from this pool. And the last pillar is getting companies into the region. So here we are talking to about 120 institutions, signed about 46 MOUs, and then working on onboarding them and grounding them, these companies. So at Meda Towers, we have an incubator, which today hosts about 70 to 80 people. So we're working there, and we have reference facilities, and we have the state-of-the-art quantum machine that is coming up, which would require huge amount of talent in this region. And we'll also be helping all the global companies in setting up their research centers and also fueling their work. So we are hoping in future, so a lot of medical devices, medical diagnostics, pharma companies coming into this region, and it would require good collaboration with hospital networks and then biofoundry network, etc., so that we can make this as an integrated ecosystem. And the best part with quantum is it is not just the technology, it is everybody's subject. The physics person will feel that it is their subject. The uh, biology learner will feel that it is their personal thing. Chemistry feels it very, very personal. So similarly, all the technology guys also feel quantum is their subject. So it's a truly multidisciplinary. There are huge amount of opportunities that are there, and it's a great opportunity for me to talk to the medical fraternity and introduce this topic to you. I would request all of you to please come down to one of our reference facilities, either at Mehta Towers or SRM University, and where we will showcase some of these innovations. It's a great opportunity, especially in sensing and sensing technologies as well as the computing technologies. Would request you all to be part of this ecosystem, like Pradyumna sir mentioned. So it is important that we need to create a lot of interesting startups in this space, and I request all the medical fraternity to work closely with Amravati Quantum Valley going forward. Thank you so much, and thank you for the opportunity, and I wish you a great learning today.
Thank you, Sridhar, Director of Quantum Computing from AP. So I request Satyanarayana sir,
Yeah.
Professor, to say a few words before starting the lecture.
Yeah. Sir, am I audible? Satyanarayana here?
Yes, sir.
Okay, great. So thank you very much for organizing this event and inviting me for this event. I am on my way to Nice, France, for attending the Bharat Innovates program. So I'm just driving to Bangalore in this process. So if there's some signal problem, please excuse me. So I just want to add a little bit more to what Pradyumna Garu and Sridhar Garu have talked about the quantum ecosystem we are creating here in AP, anchored out of Amravati Quantum Valley. Now, one of the major use cases that we've been talking about in this context is drug discovery. How using quantum computing, what would take probably, if not weeks and months on normal computers, could be done much faster, in matter of just a few minutes using quantum computing, and then accelerates the whole drug discovery process. We're also talking about, as Pradyumna Garu talked about, bioengineering, biofoundry. The whole idea is from the computing part of it, in terms of quantum chemistry and quantum biology applications, to taking it into formulations, to testing, all this, the whole ecosystem, we're trying to create a platform for that. So my request to my colleague from IIT-Delhi, Dr. Kalra, is we have colleagues all over the country in various institutions, IITs, IIC, working on the quantum research, national quantum mission and all this. And they're also very much aligned with the Amravati Quantum Valley. But if there are startups which are looking at taking off, I think the ecosystem that's being created here is where we would like to support. I happen to chair the expert committee of the Amravati Quantum Valley, and we are on track. For example, we want to get IBM's the IBM's 120 qubit machine should be up and running by the end of this year. Okay, the building is coming up fast. It's computers that's on one side is immediately creating the platforms for this computing purpose. The other side is creating the strong ecosystem for quantum hardware, where we would like to, be not only getting computers or using computers over cloud, but also making them in this country. So the reference center that Sridhar referred to, that are being set up right now, two of them. All these are the various ecosystems that, and we are planning to build over a period of time over 9 million square feet of space in this 50-acre quantum valley. So all this huge ecosystem we are trying to create. So my suggestion is on this. Now, coming to my doctor friends, Dr. Chandrashekar and I happen to serve on the board of AIM, and that's what last and I've been trying to create a lot of relationships between the medical technology institutions. I see from the affiliation of Dr. Kalra, he's also Delhi, right? But my experience, for example, I've gotten an MOU with the Apollo University that's come up in Chittoor, and similarly, I'm in talks with a couple of other institutions, SWIMS and others. The medical fraternity in general, we know they're extremely busy with their clinical work, and you know they're not able to allocate for research unless there are at least a critical mass of faculty members and work with the technology people. I think that's the only way we can make progress. I see a lot of clinical research that happens is more at the clinical level, not as much at the molecular and the cell and that level that we need to go into. So this is something that I'll work closely with Professor Chandrashekar, and how do we create a platform for these things to happen, and definitely quantum applications is one of them. So thank you very much, sir, and I will try to stay as much as possible till to hear Dr. Kalra. Thank you very much, sir, for the opportunity.
Thank you, Satyanarayana sir. I think we'll go to the main topic, quantum biology from molecule to medicine. So I request Aarat Kalra to speak.
So thank you so much to everybody for having me here. I would like to thank Pradyumna sir for orchestrating this entire enterprise of quantum bioengineering in the first place. It truly is sort of one of the world, one of its kind enterprise. We're very happy that somebody in India is thinking in such an unconventional manner. And so credit has to be given to him, first of all. I'd also like to thank Professor Chandrashekar sir for hosting me so warmly and so wonderfully here in what is a fantastic campus at NTR Health University. I'd like to thank Dr. Sudhaji for being such a kind host as well, for handling all the logistics involved to get me here. Naturally, I'm extremely grateful to Sridhar sir as well for creating the enterprise of a course on quantum biology and developing the vision for this highly multidisciplinary initiative. I've known Sridhar sir from his days at TCS as well, so it's fantastic to really be a part of this initiative. What's very exciting is that it seems that NTR Health University is ahead of its time. It seems that there's already a course on is it not yet. Right, okay. Right. So before I go into the future of quantum biology and in the future of quantum medicine, it's important to understand that you have to understand where I come from. Okay. So my undergraduate is in chemistry. Okay. My master's is in biology. And my PhD is in physics. Okay. So I have chemistry, biology, and physics, all three backgrounds. And my family's joke is I should have done a postdoc in mathematics. So I would have all degrees in PCMB. But I didn't have a postdoc in mathematics. I went to Princeton chemistry for a postdoc. And, I had the wonderful opportunity there of working with two Nobel laureates. So in the first, won a Nobel Prize, this time in physics. So that was Professor Michael Houghton and Professor Roger Penrose. And I was fortunate enough to actually publish a paper with Roger Penrose. Okay. Now, what I have developed over this very unique, very different sort of career is an appreciation for the interfaces of different fields. Okay. And that's what I'll talk about today. So interfacing quantum technology that we've all heard so much about, quantum computing, quantum teleportation, quantum cryptography, interfacing this sort of quantum technology with medicine is really one of the grand challenges of the 21st century. There is a lot of talk of quantum computing, because there's the important realization that if you're able to develop an effective quantum computer, as Sridhar sir said, it's going to be AI on steroids, right? What this will also allow us to do is it will allow us to view medicine very differently, right? And perhaps integrate, do what Pradyumna sir was saying is, integrate Ayurveda and homeopathy with the more classic, allopathy, sort of mainstream definitions of medicine. So now, for example, if you see this video that I'm showing, there are these FDA-approved therapies which use electric fields, shockingly, to treat cancer. So if you have brain cancer or liver cancer, one of the first lines of treatments now in the US is what's called TT field therapy, where they're exposing the liver and the brain to these electric fields, and they find that cancer of the brain and of the liver can actually be reduced using just these electric fields, which is shocking, right? The other big example of interfacing electronics with medicine is these wearable devices. So you've all heard of the Apple Watch, right, which can tell you how well you slept, how well your heartbeat rate, the Whoop and the Fitbit. We see Virat Kohli doing a lot of ads for the Whoop device these days. So it can tell you about cardiac arrhythmia, which Sir is of course one of the national leaders on. It can tell you about the quality of your walk. It can tell you about how your heartbeat is doing, in the middle of, let's say, a presentation. So wearable devices are another example where electronics is expected to have a massive impact on medicine. Okay. The third big impact of electronics with medicine is supposed to be photobiomodulation, using light and laser-based technology for medical treatment, and that is where the least is known, really. So we do know from like the 14th century that standing in the sun, being exposed to sunlight, etc., will have very positive medical effects. While we know it has medical effects, we're very, it seems our understanding of how light talks to biology is very poor. So this is something we need to work on in the future. It seems that all these three things, cancer treatment using electric fields, wearable devices, and photobiomodulation, rely ultimately on what Sir was saying from IIT Tirupati, which is, the molecular scale research. So that is really what has to be done. It's what Satyanarayan Sir was saying. You have to understand the molecular scale. So I'm going to show you two videos. Okay, two videos that I found very shocking to initiate this discussion. In the first, we're going to be putting bio into electronics. Okay, so this is a nanoscale hand that is light activated. Okay, and this was a paper that was published in Nature. You can see that the hand moves, and it's moving just based on light. So the hand stays still if you don't have light, but if you expose it to light, it begins moving. So you can move the fingers, you can flex your hand, you can move it left and right, all based on how you exposed it to light. Okay, and that's an example of putting a bio into what is fundamentally a mechanical or let's say an electronic device. The other example I found even more shocking, and that puts electronics into bio. So this is a video of a cockroach. Okay, and just see what happens here. The cockroach is being dictated how to move based on how I swipe my iPhone. So if I swipe the iPhone left, see, the cockroach moves left. If I swipe the iPhone right, the cockroach immediately moves right. You see? See, every time he's swiping, there you go. So this is the kind of shocking power that the interface of electronics and biomedicine has. Okay, you're able to move literally a cockroach, which is a living, breathing organism, based on your iPhone's sort of whims and fancies, right? Now, what they did here is they hijacked a very well-known neural circuit and they interfaced it with silicon-based electronics. So, and by the way, we have a similar circuit in our brains. So imagine what we could, do if we started manipulating human beings like that, right? But of course, this has problems, right? There are problems associated with interfacing electronics and medicine, and the biggest problem is that it's silicon is still the workhorse of modern bioelectronics, modern electronics. My presentation isn't moving. There it is. Thank you. Yeah. So the thing is, all these advances are very exciting, but what they've led to is they've led to a lot of industrial industrial waste. So silicon is actually the responsible for the world's largest source of growing solid hazardous waste, on the entire planet. So while progress in technology has been very enticing, it's led to a lot of let's say side effects, right? So we're familiar with the sustainability issues, with pollution, with the development comes with. And that is really the promise of quantum biotechnology, is that you're going to be able to create not new interfaces between medicine, but you're also going to be able to create novel technology for green initiatives. And this is something that's often hidden. People talk about quantum medicine and they don't realize that you develop quantum medicine, of course you save lives, but you also end up contributing significantly to the green let's say to the green movement, right? Um, so I published several papers and news articles on this sort of thing, and we're fortunate enough to have been featured twice in the magazine, The New Scientist, uh, on similar topics. Today I won't go too much into the details of the science involved, but suffice to say that there is enough evidence now to understand that quantum effects and quantum technology has direct impact on biology. Okay. And what I'll be doing is I'm going to be talking about two specific use cases. What Pradyumna sir said is very close to my heart. Research for the sake of research is probably not the best way to go forward. You have to do research that is translational and leads to products. Okay, so I'm going to be talking about two products today. So nothing very technical, just simple two products. The first one comes from the realization that India will house 50, right now we're a very young population. We're one of the youngest populations on the planet, right? But in another 30 years, young people will become old. And we're going to be faced with the world's largest senior citizen population, right? And so we're going to, in fact, host about 15 to 20% of the world's elderly by the time 2050 comes along, right? Um, in fact, even right now, we have 17 million individuals who are above the age of 60. That's a staggering number, right? And so if you look at our demographic, we have 0 to 14 is obviously about 27% of the population. Most of our population is between 25 and 54, and there's a significant population that's above 65. Now, this population that is senior has a very high chance of getting neurodegenerative diseases such as Alzheimer's disease, Parkinson's disease, Huntington's disease, Lewy body syndrome, etc. Right? And the way you diagnose these diseases is actually very unclear. Typically, what is done is you use MRI and PET, okay, along with CT scans. So you go to a clinic, and you lie down over there, and your essentially a brain scan is done in an MRI setting. Okay, these tests cost a lot of money and typically are slightly inconclusive. Okay, so you can't just look at an MRI graph and essentially prove that the person has Alzheimer's. It's a little unclear. And so patients have to undergo cognitive examinations. They have to, obviously pay a lot of money at every single stage. And ultimately, the doctor, is able to finally diagnose whether you have Alzheimer's or not. What quantum technologies, specifically this very interesting phenomenon of super radiance, does is it allows you to bridge that gap. So super radiance based quantum diagnosis of Alzheimer's disease is supposed to cost 1,500 rupees per test and is supposed to very clearly illustrate whether you have Alzheimer's, yes, or no, you don't have Alzheimer's. What is super radiance? So now normal fluorescence, which is by the way how this room's lights are powered, right? They're called CFLs. The F there is fluorescence. In fluorescence, you excite one molecule with light or with currents, and they all emit incoherently at separate times. That's how a lamp lights up. Okay, each molecule emits separately. But in super radiance, all these molecules are quantum entangled with each other. So they emit as one massive super radiant complex. This phenomenon leads to the formation of a massively emissive complex. Something that has the power of 1,000 times brighter than fluorescence. Okay, so you get brighter lights, of course, at the macro scale, but more importantly, you get brighter lights at the nanoscale. What the vision is that you can fabricate disease sensors that the moment there is even a small hint of a misfolded protein, or even 1% of your tau or alpha synuclein or any of the complexes typically associated with Alzheimer's disease or Parkinson's disease, that the moment that begins to happen, you can immediately detect it because of a super radiant signal, because it's 1,000 times stronger than a typical fluorescent signal. And that can allow early diagnosis for Alzheimer's disease. It is shocking to note that Parkinson's disease and Alzheimer's disease actually begin when the person is 30 years old. So typically, of course, I've introduced them to you as let's say old age diseases, right? 65 plus. That's actually not true. They're typically diagnosed at 65 plus. They begin to happen at 30, 35. So people who are going to get Alzheimer's or Parkinson's at 65 essentially have already begun Alzheimer's, their journey at 30 and 35. It's just that we can't diagnose it. Our vision is to catch it early, right? Using quantum biology. And if we're able to do that, right now in the world, nobody's done this. So of course, India will be the leader, needless to say, right? India Health University will be the leader. Amaravati Quantum Valley will be the leader. Not only that, but think of the lives you've saved and the entirely new set of industries that you've developed, right? So people are not calling this pharmacology or pharmaceuticals. They're calling it electroceuticals, right? Which is an interesting word, or magnetoceuticals. That's the first example that I'll give for Pradyumna sir was talking about the translating into products, right? The second product that I'll talk about comes from a very strange place. Okay, you've all heard of Saras cranes, right? You've all heard of the migration that they undergo, right? Have you heard of olive ridley turtles? They migrate from Madagascar to Odisha. In fact, are there any migratory turtles that come near the coast of Andhra? Oh, so it attracts migratory birds. Yeah. So I'll tell you something very interesting about migratory. So this is the bird's eye view that you can see now on the screen. Now this is a bird that flies from Canada to Mexico. Okay, so it's similar to what you'd see from Madagascar to Odisha, or from let's say the lake here that is that Sridhar sir is telling me about. Now, as you can see in the bird's eye view, you can only kind of make out there isn't any GPS, right? There's no Google Maps to tell it to go from Madagascar to Odisha. There's no guide saying turn left in 200 meters or slide right underneath the bridge. Estimated times 3 hours 12 minutes. None of that, right? The bird just look at this view, and how is it able to navigate 2,500 kilometers from Madagascar to Odisha, or to a lake here in Vijayawada? It's able to navigate, it turns out, because of a quantum phenomenon that takes place inside its eye. Okay. This quantum phenomenon was illustrated. I won't again go too detailed into the science, but it turns out that a radical pair forms in the flavin and in the tryptophan residues inside the bird's eye in their proteins. Okay. And essentially, if you have electrons that are paired, you have a certain product that's formed. So a certain taste comes into the bird's mouth. And if you have electrons in the triplet state, you have a different taste that comes into the mouth. So depending on the taste that the bird is tasting, it's able to decide whether I have to move left or right? That is the kind of natural biological GPS that a quantum phenomenon is able to generate. Imagine if we can navigate like this using our indigenous fighters, right? You have the LCA Tejas, right? Imagine if that is able to navigate over thousands of kilometers using ultimately a quantum phenomenon. Forget about the Tejas. Let's come closer home. What if we're able to diagnose diseases and really treat diseases using the weak magnetic fields that the birds use to develop these different tastes? So, there are several diseases that actually magnetic fields and singlet triplet dynamics that I talked to you about are where they're harnessed in. So ribonucleotide reductase is targeted by anti-cancer drugs, gemcitabine and hydroxyurea. So you must have all heard of chemotherapy, right? What now we think will happen is that if you have chemotherapy, but in the presence of magnetic fields, you can harness a quantum phenomenon here, that same quantum phenomenon, to enhance chemotherapy. So chemotherapy typically is ravaging to the person's health, right? You have hair. I don't know if you have any relatives who've had chemotherapy. It's very traumatizing. You have vomiting that takes place. There's nausea. The person loses hair. They lose memory very often. Tragically, my grandmother underwent this process, and I remember people in the family saying that, is it even worth it to undergo such a treatment? Would it not be better to just not undergo chemotherapy? Uh, Perhaps we can reduce the time you undergo chemotherapy using these quantum phenomena, right? That birds are already using, by the way, right? Alpha-synuclein is found, which is found to be misregulated in Parkinson's disease. But there might be a way of using magnetic fields to reduce that. Beta amyloid fibrils that are famous to be seen in Alzheimer's disease might get less misregulated in the presence of these weak magnetic fields. So this is really using quantum biology not for diagnosing diseases, which, remember, was my previous proposition, right? With MRI and all of that. It's to actually treat diseases. So there's two angles you have to think of. One is diagnostic products, and the other is therapeutic products. So this is a therapeutic that I am now proposing, right? So this is called spin therapy, because it relies on electron spins, right? So it's called electrospin therapy. Again, there is a lot of research in the West going on in this field. No products have come out. India and Amaravati Quantum Valley can be world leaders in this phenomenon. So I'm pitching to you that we jointly develop a product between IIT-Delhi, AQV, and NTR Health University, and perhaps even IIT Tirupati and AIIMS Mangalgiri, to develop what is truly first in the world. ICMR every year has a call for proposals where they essentially say we'll give you 8 crores if you develop something that is truly first in the world. This is truly first in the world. Can we jointly, with the CM office's blessing, can we jointly apply for such a grant with the NTR Health University, AIIMS Mangalgiri, IIT Tirupati and IIT Delhi to develop such a therapeutic. This I'm talking. This is like really game changing stuff, right? Like you'll electroceuticals will. I want Amaravati Quantum Valley to, in some sense, become synonymous with electroceuticals, right? And of course, there's a lot for the pharmaceutical industry to gain, because they can then they can really take these products home and market these products and make it their own. Of course, right now we have tech companies in the Amaravati Quantum Valley. I can see a future where we have GlaxoSmithKline, Johnson and Johnson, Laureus, Ranbaxy, etc. in the Amaravati Quantum Valley. That is really the challenge, right? And so this is the physics behind it, behind the spin therapy that I'm talking about. Don't worry, I'm not going to go into Hamiltonians and things like that. This was pioneered, some of it, by two extremely talented undergraduates at IIT Delhi. One of them is in Stanford, the other is in Oxford now, Lisha and Dhruv. We successfully showed that weak magnetic fields are able to alter spin states, right? Like I said, weak magnetic fields have already been shown in vitro to alter cell states. So here, I'll just give you a very brief example. You can see that the cell proliferation rate in the control was 4 units per hour here. But in the presence of 30 millitesla magnetic fields, very weak, remember, 30 millitesla, typical MRI is about 1 to 2 Tesla, right? This is 30 millitesla. 30 millitesla, the cell proliferation rate goes down by 4 times. See, it's barely growing at all. You see, and so this is the power of weak magnetic fields. This is a purely quantum mechanism, and you can see how dramatically it's dropped, right? Something like 4 times the cell proliferation rate has dropped. In fact, we just wrote a paper that got published in Nature Reviews Biomedical Innovations on this topic. So it's extremely useful, right? This is the title of the paper. It's called "Silent Forces, Hidden Currents: The Influence of Magnetic Field Stimulation on Tumor Biophysics." Can we develop this into a real-world product? Can we go to this? Can we develop this with GlaxoSmithKline and, of course, NTR Health University? Madam was telling me you have 200 colleges, right? So think of the power of that if we can develop joint courses together, on this with AQV. That would be fantastic, right? There is also the enticing, I talked about medicine right now. There is also the enticing opportunity of developing conductors outside medical applications. Can we build a quantum-based biosolar cell? Right? Can we use proteins and that I clearly showed you are magnetic field sensitive, are conductive? Can we build a protein-based camera? Can we make a protein-based solar cell? Can we make a protein-based OLED? OLEDs are what powers this screen right now, right? It's organic. It's called an organic light emitting diode, OLED. Can we, along with the AQV and NTR Health University, develop the world's first BLED, which is the biological light emitting diode? We immediately get a patent on that, immediately get a product on that, right? And we have the intellectual depth. So we should work on this together, right? These are the enticing possibilities that are there. The cell is replete with conductive proteins. There are microtubules, actin filaments, DNA has been shown to be conductive, collagen. 75% of your body weight is made up of collagen. It is the most abundant protein known to man. You get it by the kilo. It's found in rivers as part of organic waste. Can we use collagen fibers to develop a protein-based wire? Prion proteins that are found in mad cow disease, beta amyloid plaques, viral membranes, all of these are highly conductive, right? Can we develop? So I'm talking, this is not just medical now. I'm talking, taking it to the next level, sustainability initiatives, biological computers, biological cameras, like I said, OLEDs, solar cells, etc. Our lab just showed in a PNAS. So there's a journal called Proceedings of the National Academy of Sciences, PNAS. Okay, and we found that the conductance of proteins can be as high. It can take place over 80 nanometers actually, which is a shockingly high length. Typical conductors expected in proteins were supposed to be 4 to 6 nanometers. We've shown that it's 80 nanometers. Silicon is 200. Okay, silicon is 200 nanometers, the diffusion length. 80 is not as high as 200, but it's still extreme. It's like 10 times higher than what was expected, right? So this sort of research clearly shows that there is a potential of developing protein-based technology and bio-based solutions, right? Bio-based technological solutions towards sustainability. Can we develop that sort of device? There is a lot of international interest in quantum biology. The Nobel laureate Roger Penrose has agreed to be part of this initiative. Greg Scholes came from Princeton to IIT Delhi this March to discuss quantum biology and India's quantum biology initiatives with me. Stuart Hameroff is with us. Jack Tuzinski is with us. Together we can really develop Amaravati Quantum Valley and NTR Health University into a quantum biotech hub, not just for India, but really for the world, right? I mean, I have to congratulate you that you're even thinking in this direction. Ultimately, this is truly already one of its kind initiative in the world. I was just reading, going over various news articles, and it's already there in the media, right? The Honorable Chief Minister has already taken the lead in this direction. Well, I guess we don't have audio, but that's okay. So the 21st century will be the quantum technology century, and I am hoping and expecting that we can do something together also with the Amaravati Health City and with the Amaravati Medicity, right? So AQV will pioneer it in collaboration with NTR Health University, AIIMS Mangalgiri, IIT-Tirupati, etc., towards interfacing quantum technologies with medicine. I just gave you two fully complete use cases, right? One is in the diagnosis of Alzheimer's disease, and the other is in the treatment of cancers, right, using magnetic field therapy. So we're developing a course right now, a small 3-day-long course called Quantum Biology from Molecules to Medicine, with the blessing of the Amaravati Quantum Valley. So that's going to be taking place at the 31st of July to 2nd of August. Okay. So please feel free to tell your students to join in on this very exciting, truly unique initiative. We're very excited to, and what we're going to do is we're going to teach students the principles of quantum biology. So students come with medical backgrounds, right? And essentially they don't know anything about quantum tech. So we will bridge that gap and teach them about quantum initiatives. But the other thing is that engineers come with very little knowledge of biology and medicine. So we will teach engineers biology and medicine. So we have AIIMS New Delhi doctors teaching us about therapies, and we have IIT-Delhi engineers telling them about quantum technology. So it's a true interface. It's a true. You have these wonderful, thalis here, right? So it's a thali. I view this course of quantum tech and medicine coming together. So with this, I thank you for your attention.
Thank you, Professor Karla, having given us introduction on the quantum biology from molecule to medicine. I think we'll interact with the people. We had with us the paramedical board secretary. No? Secretary is there. I think we nuclear medicine, BSc nuclear medicine is there already in SWIMS Tirupati. I think we can also start the course. The only thing is we should have a full-fledged department where should have a MRI, CT, and also PET scanning and all. I think very soon the of course AIIMS Mangalgiri and also SWIMS are well equipped. We wanted to see the upgrading of the radiology department. I think very soon. I'm very happy that the early detection of Alzheimer's can be made by the quantum biology, and also I think we'll definitely have interaction with you, IIT New Delhi, and also the IIT even at Tirupati. We got our own institute director Satyanarayana is also helping us. So in coordination with the AIIMS Mangalgiri director and all, I think we'll definitely start certain things. I think very soon we'll be starting we'll be introducing the syllabus in the medicine, and also I think we can start the BSc course in the in the nuclear medicine, and also there's a physics.
Yes, sir. Medical physics.
Medical physics is another one where we can start in the medical physics also. We can start this quantum. This one, I'm extremely happy that at the age of 32 years he has become the professor of IIT. I have to congratulate you that the medicine, particularly the India, we got a depth of knowledge. As you know that most of the NRIs are the drain has taken place. I think the many people come and settle down in India itself. I think we are in the forefront. Andhra Pradesh in the forefront in technology, particularly on the leadership of Nara Chandrababu Naidu, and also the Health Minister Satyakumar Yadav, and also our Secretary, President Secretary Saurabh, and Pradyumna Garu, Special Secretary to Honorable CM. So definitely we'll start this one. So I request the audience, different colleges, I think they have participated today in the webinar. I request you to pose some questions regarding this.
I request the principals, vice principals, and the other faculty to be a part of the discussion of this session. And what are the doubts or the queries you are having, you can discuss with Karla sir.
Good morning, sir. This is Dr. Devi Madhavi, Principal Government Medical College, Vijayawada. At the outset, I'd like to thank the entire administration, right from our CM to our Vice Chancellor, Honorable Vice Chancellor, for providing this wonderful opportunity. Most of us did not know what it was when the topic was actually shared with us, especially the seniors. But, and today it was very insightful, the inputs given by the various speakers and the guest persons. And finally, Dr. Kalra, he's given us a very lucid and clear like you would say, an introduction to how we can apply this quantum biotechnology and how the future of medicine is. So, like for me, as a senior faculty, it may not be easy to adopt change. However, I'd like to know, sir, like we have for the undergraduates under the NMC curriculum and component like electives, where the students, after they finish their community medicine in the final year, they can be sent to different institutes to know more about and work on this. So I would like to ask our Honorable Vice Chancellor whether we could have a collaboration with any other institute within the state, or where we can send some, at least some interested students, sir, for 15 days for this program.
So definitely, I think those are interested, particularly the faculty and also students. I think he has given a brochure. So there is a continuing medical education program, online class for 4 days, and quantum biophysics. I think fees is around 5,000.
Yes.
I think they will have an insight. I think this is a new syllabus that we have to introduce in the Board of Studies in collaboration of NMC. Then only we can start this one. I think this will be definitely useful in radiology and also like in phototherapy, particularly for neonatal jaundice and all. I think this is welcome because our honorable CM vision, Chandrababu Naidu, we are in the forefront. Definitely, in due course of time, we will be starting this one. So I request all the principals and also some of the students, they can join online. We'll circulate to you about this CME for July 31st to 1 to 3, August 1st and 2nd and 3rd, 4 days workshop. You can online by paying how much?
3 days. 3 days. Sir.
3 days. 3 days. I think 5,000 rupees. I think this will be definitely will be useful. I think, as I said, the principal of Government Medical College Vijayanagar will definitely think of it. We have to keep in the board of studies. I think paramedical secretary has also come, that we can even start a graduation course on the medical physics. All these things are related. I think nuclear medicine, BSc nuclear medicine, and all will be starting in due course of time. I think, as you said, is in the first year, our people are overburdened with the three subjects: anatomy, physiology, biochemistry. As you rightly said, I think in the fourth year at the SPM, I think we can start this small introduction of this course, so that people, as a Pradyumna said, our people should be, doctors should be educated, knowledgeable regarding this. So thank you, Principal Garu, so Vijayanagaram. I think I request others to give their inputs.
Thank you, sir.
Good afternoon, sir. I'm Dr. Vinay, pharmacology professor from Ashram Medical College. At the outset, I want to thank sir for giving such a great opportunity and trying to bring a course where much emphasis will be given on quantum mechanics, quantum physics, and electronics also. And all these things are going to help us. And I want to thank sir. And recently, I have attended a workshop on zebrafish models and all, where how the zebrafish are working, and even the neurons that have been taken has been connected with electronics, and how certain activities they have demonstrated. It is completely a wonderful experience, sir. I think with a course like what you are going to introduce, more such ideas will come and we will proceed forward in meaningful manner, sir. Thank you.
Thank you.
Anybody? From Gayatri Medical College? I request all the principals, as you know, that we are spending almost 13 crores for the research. Undergraduate, this one scholarship we are given to almost each person around 30,000 rupees for 1,000 students. So it is coming around 3 crores from the university. And the faculty research grant, almost 5 lakhs per person for 200 faculty members, including the postgraduates, in all the affiliated colleges. So take the opportunity and start doing some, apart from the clinical work. As you know, the clinicians are busy in the patient care and practice and all. But only thing is, you should have a sharpen your minds. I think we'll have a lot of cooperation with IIT New Delhi, and it will be in a combination of IIT Satyanarayana is there, Professor Director of IIT Tirupati, and also the AIMS of Mangalagiri. Definitely, we can start some new courses and utilize this opportunity and start doing some research. So, apart from the regular affair, so this is what we wanted to tell you. The principal, SU Medical College Tirupati, sir.
Sir, good afternoon, rather, because it has already crossed 12 o'clock. It is, I think we are very thankful to the Vice Chancellor, Dr. Chandrashekar Garu and his team for organizing this kind of WebEx workshops very regularly. So previously it was never held so regularly. And today, of course, this topic was definitely different from our medical field, but from what Doctor has elaborated on these principles. It was very candid and very clear, as Dr. Devi Madhavi was also telling. We really got a lot of benefits. As he was telling, we'll definitely try to put it into practice by involving this kind of knowledge into our medical field. And once again, we thank the speaker for bestowing his attention, giving us enlightenment on this topic, which is very unclear to us. Now it has at least some awareness we have got on this field. Thank you, sir.
You're most welcome, sir.
Good morning, sir. I am Dr. Chandrashekar from Rangaraya Medical College, Kakinada. I should thank you for having this beautiful presentation of quantum biology. And I thank VC sir and for organizing this webinar. And one thing I want to know, the pharmacology postgraduates will get benefited from this quantum biology for the development of the clinical trials, because some of the postgraduates are very much willing to go to industry side. So in that aspect, can you conduct any separate workshop for postgraduates in pharmacology? It will be very much useful for them.
Definitely,
Sir, because
because you have done a DM
DM
pharmacology, I think this line, I think
uh,
we
we
can
can definitely start. I think we'll have with IIT Tirupati and also IIT New Delhi. I think we can send them for some training also. So, as I said, one is a drug discovery is also definitely plays a important role. I think there is the pharmacy institutions also in due course of time it will come to the health university. So in South India, most of them are independent and they're attached to the various universities. I think a number of B Pharma, M Pharma, all these things I think will come under health university. I think very soon even the government is thinking pharma university also. So before that, I think when I inquire with the Tamil Nadu, Kerala, and Karnataka, the pharmacy colleges are under the health university. I think you are a pharmacologist. Definitely, we'll definitely take inputs and we'll try to send the postgraduates for this training. So we'll send the brochure of this 4 days, 3 days workshop on quantum biology. I think those are interested, particularly the faculty and also students, they can enroll themselves on online this one so that we will have a interaction with this. I think in due course of time, very soon, we'll be introducing this type of courses, and we can definitely send the postgraduate students for the cooperation of IIT New Delhi and also IIT Tirupati. Sir.
Thank you, sir. Thank you very much.
Nice.
So good afternoon, sir, from Kalra Medical College, sir.
Okay, ma. Good afternoon, ma.
Sir, small request, sir. PPT కూడా కొంచెం షేర్ చేస్తే subject is more
keeping. So
Okay.
you see all the webinars will be there in this one. So you update. We are updating even the website and all. Don't worry. So we'll also share some slides. I think with the request of this
Thank
one.
you.
See that you utilize and tell your students and also the poor, but particularly undergraduates and postgraduates. Some of them they'll be good. You just encourage them to come
Yes.
up with the flying curves so that we can increase the NAC ranking and also NIRF ranking, because
Definitely.
we are not there in the first 300 also, only except Usmania, it is in the 50th rank. So request you to, you see, put a keep an eye over the research angle, and anyhow, very soon we will be starting DMDC, Disease Modeling and Decision Center is ready to accept for recruitment. I think we are spending 6 crores from the University of Health Sciences. So another 13 crores for the research. So some people they are very, very intelligent. See, as Kalra, I think some of the IITs, they've excelled their field. I think in coordination with this IIT people, I think we can make wonders as India is progressing, particularly in Andhra Pradesh, we are progressing much better than compared to the other states.
Thank
Any
you.
other things? Okay.
Good afternoon, sir.
Good afternoon.
I'm Dr. Aditya from Government Medical College, Vijayawada. Sir, I have done my MD from AIMS New Delhi and currently placed in the Department of Physiology. Sir, first of all, I really thank Dr. Kalra for having this wonderful lecture on quantum biology. Sir, we have couple of doubts regarding this topic, sir. The first one regarding we have certain concepts like electron theory of metabolism. So, is that somewhere linked with quantum biology, sir?
Absolutely. I'm not familiar with the exact details of electron theory of metabolism, but I mean, links can be established with these theories as well. So I mean, there are definitely links that quantum biology has with aging and with differentiation of stem cells and things like that. So I wouldn't be surprised if something does emerge.
Okay. Sir, I was also going through your complete profile and your publications in Google Scholar. So I have seen that you have much work on this proteins of actin and polymerization of the proteins. Sir, and also you have started your lecture with this brief introduction of the behavioral change with some changes in the electricity, like quantum theories of phone, which is changing the behavior of a cockroach. Sir, I have this specific doubt that even though we say changes in a gross morphology, but can we see it through its mechanistic view that how exactly this quantum energy is influencing on the protein or the receptor, which is causing this behavior?
Right. So in this case, in the cockroach video, we do actually understand the molecular level, what's happening at the molecular level, and what's happening there is that the neural pathway that is responsible for movement has been hijacked using a small implant made in the cockroach's nervous system. So you can now electrical signals, of course, that go to this neuromuscular system are ionic in nature, right? In a normal, healthy animal. But you can hijack this system if you make a small implant. You do essentially a small surgery on the cockroach, and you implant something that is like a microcontroller that interfaces with a remote or with an iPhone. Every time you switch it on, or left or right, it goes and it puts in an electrical signal into that neuromuscular junction that allows those ion channels to be excited, initiating an action potential over there.
So in similar lines, the just question extends into this view that if we apply this knowledge into a drug delivery system, so
Right.
how we can be sure that this electron or the energy which is generated is influencing again a protein dynamics or the receptor changes, and which causes maybe the cure of the disease? Because you have touched upon the diagnostic part, how we can see even in earlier stage, which will be used for the preventive care, but how it can be used for the early treatment or the precise medicine.
Right. So the way it can be used for early treatment is through spin therapy. So that's a different example. That was the later part of my talk. What you do there is you expose your system. Say you have cancer. Okay, say there's the skin cancer, for example, right? And the skin cancer tissue is exposed to a weak magnetic field. Now, what this causes is there are, of course, electrons within biomolecules, right, that are inside the tumor. These electrons are present in these free electrons are all over the place in electron transfer chains, right? So the mitochondrial membrane has an electron transfer chain, ribonucleoside reductase has an electron transfer chain, etc., etc. Every time an electron gets transferred, you form what is called a radical pair. Okay, so you have something, a donor plus, acceptor minus, right? It is shown that the spin state of this state can be altered in the presence of a magnetic field. So singlet or triplet. Now singlet or triplet is this is slightly physics language. Okay, so let me just tell you in simple terms. So whether the electron is spin up or whether it's spin down. Okay, that can be exchanged if you have a magnetic field. So it's spin up if you have a magnetic field, spin down if you don't. Okay, it turns out if it's spin up, the system is extremely reactive. So essentially, the cell dies if it's spin up, and it becomes spin up if you have a weak magnetic field.
So using the external energy, we can modulate and give for a precise.
Yeah. So external magnetic field, to be precise. Yes. So you can modulate whether it is spin up or spin down in electron transfer chains, which will ultimately kill the cell. So all you need is a 2% change in the spin up, spin down, and that is enough to essentially throw off a cell to lead it towards its death. The advantage of magnetic field based therapy is that it's completely non-invasive. So you're not doing a surgery, right? Typically, how is skin cancer resolved? It's resolved through what are called resections, which I'm sure you know better than I do, right? Now we don't have to do resections. All I'm saying is you apply a north pole, south pole, and you click the button on, and that's it. And it's of course very inexpensive also, right? Because so the cost of the entire magnetic field apparatus would be something like 500 rupees. Which is much cheaper than financially than other mechanisms. Yeah.
Yes. Thank you, sir.
But great question.
Yes. And sir, last question, sir. So can we get access through any dry labs, but using this quantum?
Of course. So there are two ways of getting access to a dry lab. One is you can come to IIT-Delhi, and we're happy to host you. That is the long way of getting access to a dry lab. The short way of getting access to a dry lab is hopefully in the coming future through innovators like Sridhar sir in the AQV. We are conceptualizing the development of a quantum bio lab here itself in Amaravati / Vijayawada. If that happens, that would be the site where you go and essentially try out some of these ideas that you're talking about.
Yes. Thank you so much, sir. Thank you.
Great.
Thank you for innovative question. Anybody? Request Sridhar, Director.
Thank you, sir. Again, thank you for hosting this wonderful conference. So again, because all the medical fraternity is there, I just want to say that at AQV, we are trying to work on some of these interesting technologies that forms the foundation of medical devices like photonics, optics, superconductors, NV center magnetometers, and a lot of instrumentation. So which would require good amount of semiconductor and VLSI based technology. So we are now challenging any machine that we see in our lab, can that be made in Amaravati Quantum Valley? So that is the discussion that we are having. And we are also having a very diverse workforce coming from different countries who are trying to work on these technologies. So we made the dilution refrigerator. Now we're working on the subcomponents of the subsystem that goes for superconductivity. So which means theoretically we can make any instrumentation. So this is the most complex instrumentation that we are working on. So I would request all of you to also come up with challenge statements, because you must be working with so much of diagnostic instrumentation and therapeutic instrumentation, and these things internally would be using lasers, photonics, the semi-center magnetometers, and in fact, one university, University of Nottingham, which is also the inventor of MRI machine. So now they're working on NV center diamond technology, which transforms a big MRI machine into a small helmet with about 16 diamonds, which can actually perform much better than the MRI machine. And these are the technologies that are shaping up in the quantum world. And we at Quantum Valley want to host some of these startups who are interested to work on these kind of technologies. Through National Quantum Mission, so we have a very nice ecosystem shaping up, who are building these photonic sensors, single photon detectors, NV center diamonds, and the magnetometers with NV center diamonds, etc. So, and quantum imagers. So all these are also useful in healthcare and diagnostics. Would request your support, and if you have any ideas, please feel free to reach out to us at Amaravati Quantum Valley, and we'll very closely work with all of you. And we look forward to you please joining into the Amaravati Quantum Valley framework. Thank you so much.
This is a brochure, I think we'll circulate to you from the university also, the quantum biology from molecular to medicine. I think it will give us a bird's eye view, and some of you are interested. I think you can become a scientist from the doctors community. So, any questions further? Minimize it. Any other questions? If there is no questions, I think I request the register to say few vote of thanks.
Good afternoon to all the dignitaries. And first of all, we should be very thankful to your Honorable Chief Minister Chandrababu Naidu sir for his vision with reference to this Amaravati Quantum Valley, which is his brainchild, and supported by many bureaucrats and the scientists and the technical persons and experts in this field. And this is also extending into our medical field. So when I'm listening to the lecture of Professor Karla sir, so really we are wandering in a new world there. So in future days, there may not be any surgeries or any investigations or any operations or the drugs will be there. So everything, whatever it may be, it will be cured by the dynamics of the components of any cellular components. So in near future, we are seeing it. So we should be also ready with the advanced technology with reference to this quantum artificial intelligence and green energy, drug discovery. So many things are there. And the university is also introducing so many courses with the advice of our Honorable Vice Chancellor, sir. So we are going to introduce the then biophysics, then quantum biology, and some more new courses. Already there are some instructions from the government and the higher authorities. So to start the bachelor degree in the nuclear medicine technology, and which is already present in the SWIMS. And sir, our VC sir is also taking the initiative steps to start these courses under NTRUHS also. And I'm very thankful for the participants of this session and their valuable suggestions and queries, which made the session more fruitful. I most thankful to our Karla sir coming all the way from the Delhi to our university and giving a insight to all of us and giving a new vision. And also very thankful to Dr. Sridhar sir, and very thankful to for Pradyumna sir, who is the initiative behind all these things and making this session more lively with his introduction to the quantum biology. And finally, we thank our Vice Chancellor sir, for making all these things possible. And in future, definitely we'll go ahead with the new things. Thank you, thank you all.
Thank you, Mr. Sridhar. Sai Sudhir, and definitely apart from the quantum reason, I think very soon we'll be introducing artificial intelligence to all the colleges, affiliated colleges, both medical, dental, and I think very soon even noise department also. I think utilize this opportunity. Definitely, we should be in the forefront because the university is first university of its kind in the country. Then the other states they have followed it. Keep up the um, good work and try to bring the laurels to the university. So with this small felicitation to our Karla, Professor Karla Garu, before we end the program. Thank you.
Sir, ready, sir? Okay, sir.
Okay. Come all of you come. Ready, ma? Done. Cheers. Okay. Stop. Thank you. Thank you so much, sir.